Hello, am I audible?
Yes, ma'am.
Okay, so good afternoon, all of you. Today, again, we are going to deal with Boolean algebras. Last lecture, we have seen some examples based on Boolean algebra. So, basically, the definition of Boolean algebra is consist of B, then three operations on Boolean algebra, that is star operation, XOR operation, and complement operation. And next part, that is for 0 and 1. So here 0 and 1 are the bounds of that lattice. So we have defined Boolean algebra as distributed complemented bounded lattice is a Boolean algebra. So after that we have seen what is the definition of sub Boolean algebra, or we can say sub algebra.
Hello, ma'am. Screen
Hello, hello.
screen is not visible.
Okay, just now is it visible?
Yes,
Okay,
ma'am.
yes.
Yes, ma'am.
So what is sub algebra? Subalgebra is a subset of given algebra. So, in order to be a subalgebra, it must satisfy three conditions. We have seen in last lecture, but still I am going to repeat it. If B star XOR complement 0 1, this is the given Boolean algebra. Then another algebra S is called as subalgebra of B if and only if first condition, if S is subset of B. Second one, if S is closed under operations star XOR and complement. And third one, if 0 and 1 are present in S, then S is called as subalgebra of B. So it was the definition. Now after that we have seen how to recognize whether given algebra or given set is subalgebra or not. So for that they have given one note. It is not necessary to check for closure with respect to all three operations star, XOR, complement, nor it is necessary to check whether 0 and 1 are in S. Only closure with respect to set of operations star complement or XOR complement is enough to guarantee the S is subalgebra. Okay, so here they have mentioned, suppose we have to check whether given algebra is subalgebra of that algebra is subalgebra or not. In that case we have to check with respect to only two sets. First set star complement and second one XOR complement. We need not to think about whether 0 and 1 are present in that set, whether it is closed under all three operations. That is not necessary. Just you have to check whether it is closed and under star complement or XOR complement. This is necessary condition. So based on that we have to solve one example. From that you will get idea. So this is the given diagram, or we can say Boolean algebra. So from this Boolean algebra they have drawn five subsets. Okay, S1, S2, S3, S4, S5, and different elements are there. So from these sets we have to recognize whether from all these five sets what are the sub algebras of given algebra. So first set I will check. I will tell you how to check whether it is subalgebra or not. So that detailed explanation I have given here. So here set S1 is given as 0, A dash 1. Okay. So that is given here. So what we have seen? We have to check whether that set is closed with respect to star complement or XOR complement. So here I have considered that set as XOR complement. So I am going to check whether all these elements are closed under XOR and complement operation. Now check here. How to check whether it is closed under XOR? We can consider any two elements from this set and then we will check whether it is closed or not. So 0 XOR A. So answer for this one is 0 XOR A. It is A because 0 is the lowest element and A is the highest element here. That's why 0 XOR A, it is A. Again 0 XOR A's complement. So answer will be A's complement. Then 0 XOR 1. So again 0 is the least element, 1 is the greatest element. So we are going to consider 1 as an answer. Then A XOR A's complement. So look at this diagram, you will get here A XOR A's complement. So A and A XOR both are meeting at point 1. So answer for this one is 1. So likewise, if you solve all the examples or all the pairs, you will get answer that will be included in this given set. So once you perform this XOR operation, again you can take pair of elements like A and 1. So A XOR 1, answer is 1. A dash XOR 1, answer is 1. So look at the answers. What answers we got after XOR operation? A's complement 1. And check here, all those elements are present in this given set S1. That's why we can say that this set S1 is closed under XOR operation. Okay. Now, what we have seen? In order to be a subalgebra, it must be closed under either star complement or XOR complement. So here where we have checked with respect to XOR. Now we have to check for complement operation. Now check whether complement of each and every element is exist here. So consider first element 0. So 0's complement, it is 1. Yes, and 1 is present in given set. Now check for the next element 1. 1's complement is 0 and that is present in given set. Now take another element A's complement. So again its complement is A because here complement gets cancelled and you will get answer as just a minute. So complement of A, that is A's complement. So we can say here all the elements after complement are present here in this set S1. So S1 is closed under operations XOR and complement. That's why S1 is subalgebra of given set B or given algebra B. Have you understood this example? Hello? If you have not got, then I will explain it once again.
Explain.
Okay. So here in this question they have asked check whether S1, S2, S3, S4 and S5 are subalgebras of given algebra, and that diagram is given to you. So from that you have to recognize which one are subalgebras. So let us consider first set, that is S1, and S1 it is containing elements as 0, A dash and 1. So 4 elements are there. So according to note, what we saw there, we have to check whether that set is closed under either star complement or XOR complement. So आपल्याला काय करायचं आहे, प्रत्येक सेट एक तर स्टार कॉम्प्लिमेंट ह्या सेटसाठी क्लोज्ड असला पाहिजे किंवा XOR कॉम्प्लिमेंट. सो इफ that set is closed under one of these sets, then we can say that that set is subalgebra. Okay. So for this set I have taken the set to be checked as XOR complement. So XOR complement, that set I have taken. So I have to check whether all the elements of this set are closed under this operation, that is XOR and complement. Now first apply XOR operation on elements of this set. So we can consider 2 elements at a time and we have to check whether it is closed under XOR operation. So what is meaning of closure? So once you perform that XOR operation on any 2 elements, whatever result you will get, that should present in given set. Then only we can say that S1 is closed under XOR operation. So for that purpose, I have considered first 2 elements as 0 and A. Now apply XOR operation on these 2 elements. So 0 XOR A. So answer for this operation is A. So for that purpose, you can take that diagram for reference. Check here. Okay. So here 0 XOR A. So for these 2 elements 0 and A, XOR operations means what? We are going to check least upper bound. So for this least upper bound is A. That's why answer for this XOR operation is A. So likewise you can apply XOR operation on any 2 elements of that set. So likewise again I can consider 0 XOR A dash or A's complement. So again you will get answer as A's complement. So next pair I have considered as 0 and 1. So 0 XOR 1, answer is 1. A XOR A dash, answer is 1. And A XOR 1, answer is 1. Why answer is 1 here for this XOR operation? A XOR 1. XOR operation means what? All the time we are going to check for greatest element. So for this pair A and 1, greatest element is 1 here, because for that diagram 0 is the least element and 1 is the greatest element. That's why answer for this XOR operation is 1. Again next one is A's complement XOR 1. So again answer for this XOR operation is 1. So look at the results. What results we got? A dash and 1. So we can say that all these elements or all these results are present in S1. Check here, A is present, A dash is present, 1 is present. That's why S1 is closed under operation XOR. Up till now, have we understood how we have checked whether S1 is closed under XOR
ma'am.
or not? Okay, good. Now, for this set, that is XOR and complement, just one operation is remaining and that is complement. Now we have to check whether this set S1 is closed under complement or not. So for that purpose, we have to take complement of each and every element. So let us take complement of first element, that is 0. So 0's complement answer is 1. Okay. Now next element is A. A's complement is A's complement, that is given here, and A's complement's complement. So again here complement will get cancelled and you will get A, and one's complement it is 0. In short, after taking complement of each and every element, you will get 1 0 A dash, and all these elements are present in this set S1. That's why we can say that S1 is closed under complement operation. So again we can say that S1 is closed under both XOR and complement operation. That's why S1 is subalgebra of B. Understood now? Hello?
Hello, ma'am.
Yes.
In first, A XOR A dash is equal to 1. How it is?
Yes. Okay. So I have not drawn here the diagram once. Let us see here. That I have written from this diagram only. So A XOR A dash. Okay, or we can say A's complement. So what is the value for this XOR operation? A XOR A's complement. We are going to check where these two elements are meeting at greatest point, and that point is 1. That's why A XOR A dash is 1. Understood?
Yes, ma'am.
Okay. That is drawn from this diagram only. Just problem is that I have not drawn that diagram in these examples. इथे ती परत डायग्राम ड्रॉ केलेली नाहीये, त्यामुळे तुम्हाला मी ओरली सांगितलं. Okay. So likewise we have to check whether S2, S3 and S4, S5 are subalgebras. So what they have given for S2? So set S2 that is equals to 0, A's complement XOR B, A star B's complement and 1. So we have to check whether this is subalgebra of B. So again same strategy we have to apply. First we are going to check it for XOR and complement. If S2 is closed under both the operations, that is XOR and complement, then we can say that S2 is subalgebra. Okay. So first let us check for XOR operation. So 1 XOR A's complement XOR B. So what will be the answer for this first XOR operation? Okay, so just look at this diagram and tell me what will be the answer for this XOR operation. Okay, so this is the diagram. So 1 XOR 1's complement XOR B. So what is the answer here? Why you are taking this much time?
1.
Yes, 1.
One.
Because here is correct. Because again we have to check which one is the greatest element. So likewise you can check for another pair of elements like 0, x or a star b dash. So if you consider
A
these two
star B.
elements, is what is the answer for this XOR operation? A star B
B
dash.
dash.
Is correct. So likewise we can check for any pair of elements. You will get answer. That answer will be present in this set S2. That's why we can say that S2 is closed under operation XOR. Now we have to check whether it is closed under complement operation. So for that purpose we have to take complement of each and every element. So let us consider first element, that is 0. 0's complement is 1 and that is present here. Again 1's complement is 0. Again next element is a dash XOR B. So here we have to take its bracket complement. So what is the answer for this complement? So again A's complement. In short, that complement will get cancelled. A will be there and XOR's complement, that is star operation, and B's complement. So answer for this complement is A star B's complement. Okay. So now check complement for next element, that is A star B's complement. You have to take whole bracket complement. काय येणार आहे आन्सर? A's complement XOR B. So again that answer is present here. So we can say that after taking complement of every element, whatever answer you will get, that answer is present in this set S2. So we can say that S2 is closed under operation complement. So likewise S2 is closed under both the operations like XOR operation and complement operation. That's why S2 is subalgebra of B. Understood?
Yes, ma'am.
Okay. So likewise you have to check for remaining ones S3, S4 and S5. So I will open that example here. You have to tell me whether remaining three are subalgebras or not. So up till now S1 and S2, these are the subalgebras. Now check for S3, S4 and S5. Take time of 10 minutes and tell me whether these are subalgebras. For that you have to solve this example on paper. Then only you will get. Because at each time you have to check whether that given set is closed under XOR complement or star complement operation. Then only you can decide. Take your time, solve it, and then tell me whether these are subalgebras. Hello. So what about set S3? Whether it is subalgebra?
No, ma'am.
No. Why? Just give me explanation. From that I will get how you have decided whether it is subalgebra.
Here, in this S3 set, 1's complement is 0, but 0 is not
Yes.
present. And
Yes. Good.
A star B dash bracket complement is A dash X or B.
Okay.
This also
That is
not,
also
not
not here.
present. Yes, ma'am.
Okay. So from only complement we can decide whether it is subalgebra or not. Correct. That's why S3 is not a subalgebra of given algebra. Now check for S4.
It is also no, ma'am.
It is also not a subalgebra because again there is not present any complement, because if you consider element 0, zero's complement is 1, but that 1 is not present here. If you consider b's complement, then its complement is b, but that element is also not here. So likewise we can check, and S4 is not a subalgebra. And what about S5? Whether S5 is subalgebra?
No, ma'am.
No. So again, zero's complement is 1, 1's complement is 0, that is fine. But if you consider element 1, 1's complement is 1, a's complement is a dash, but that element is not here. Again, b's complement, that is equals to b. So that element is not present here. That's why S5 is not a subalgebra. So from out of these 5 sets, only S1 and S2 are subalgebras of given algebra. So likewise we can check. So based on this they have asked question for 4 marks. Check whether following subsets or subsets are subalgebra of given algebra. Have you understood this example? Hello?
Yes, ma'am.
Example समझ okay, good. So now we have to check next definitions, that is direct product homomorphism. So again, how we have defined direct product of lattices, likewise we have to define direct product of Boolean algebra. So here for that purpose we have taken two Boolean algebras. First Boolean algebra is B1 star 1 XOR 1, then complement 1 0 1 and 1 1. So why we have given that, what we can say, at lower side we have written 1 at every operation, like b1 star 1 XOR 1 complement 1 0 1 1 1, because that 1 represents, this is the first Boolean algebra. Okay, and we have taken second Boolean algebra as b2 star 2 XOR 2 double complement, then o, that is 0 2 and 1 2. So at the time we have taken 2 at each and every operation. So this 2 represents, this is second Boolean algebra. So these are two Boolean algebras. Then direct product of these two Boolean algebras is defined to be a Boolean algebra that is given by, so how we can represent direct product, b1 cross b2 or b1 direct product b2. So once you take its direct product, that star operation will be given as, that is star 1 direct product star 2, that is equals to star 3. Again XOR 3 complement 3, then 0 3 and 1 3. So for this we have taken a two order pairs of elements like A1 B1 A2 B2. Then direct product is defined as A1 B1, then XOR star 3, that is equals to, check here, we have taken two order pairs A1 B1 and A2 B2, and we have to define this operation star 3. So again consider A1 A2, these are the elements from first Boolean algebra, and for this we have taken operation as star 1. That's why this is equivalent to A1 star 1 A2, then B1 B2, these are the elements from second Boolean algebra, and for that we have taken operation as star 2. That's why B1 star 2 B2. This is for XOR star operation. So likewise we can check for XOR operation. So again we have to take these two order pairs as A1 B1, then XOR 3 A2 B2. So this is equivalent to A1 A2. So these two elements belongs to first set, that is B1, and for this B1 we have written operation XOR operation as XOR 1. That's why this is equals to A1 XOR 1 A2. Now next pair of elements B1 B2, and B1 B2 belongs to second Boolean algebra, and in that Boolean algebra XOR operation is XOR 2, that is B1 XOR 2 B2. Now we have taken, that is XOR 3 operation and star 3 operation. Now just one operation is remaining, that is complement 3 operation. So how we can define this complement 3 operation? A1 B1 3 times complement. 3 times complement means what? This is for direct product of these two Boolean algebras. So first A1 belongs to first Boolean algebra, and their complement operation is written as just single complement, and B1 belongs to second Boolean algebra, and there we have written complement as double complement. So B1 double complement. Now if you consider 0 3, 0 3 means what? Again we have to check what similar elements are present in B1 and B2. So for this 0, again for B1 0 1 is there, and for B2 0 2 is there. So these two elements will belong to 0 3, and for 1 3 we have taken 1 1 and 1 2. So this 1 3 will consist of 1 1 and 1 2. So likewise we can define direct product of two Boolean algebras. Have we understood this definition? जशी आपण लॅटिससाठी डिफाइन केली होती तशीच डिफाइन केली आहे, जस्ट ऑपरेशन्स थोडे जास्त आहेत. Shall I explain this once again? Yeah.
Yes,
Okay,
ma'am.
fine.
Yes, ma'am.
Yes, ma'am. Yes.
Check here. Two Boolean algebras are given. First one B1 star 1 XOR 1 complement 1 0 1 1 1. So why we have written 1 for each and every element? To represent this is element from first Boolean algebra. Up till now it is fine. इथपर्यंत समजलंय का बुलियन अल्जेब्रा कसा डिफाइन केलाय? ओके, सो नाउ check for second Boolean algebra, that is B2 star 2 XOR 2 double complement 0 2 1 2. So again we have represented here each and every element by 2. To represent this is element from second Boolean algebra. Okay, so these two Boolean algebras we have taken. Now we have to define direct product of these Boolean algebras. So that direct product will be given as B1 cross B2. So B1 cross B2 means what? Direct product of B1 and B2. And once you take direct product of XOR 1 and XOR 2, you will get XOR 3. Again, if you take direct product of star 1 and star 2, you will get star 3. So that is represented here. Once you take direct product, what operations you will get, that is defined here as B1 direct product B2 star 3 XOR 3 complement 3 0 3 and 1 3. Means what? Boolean algebra. What Boolean algebra you will get after taking direct product. So to represent this, we have considered two order pairs A1 B1 A2 B2, and these two order pairs belongs to B1 direct product B2. म्हणजे काय, जर डायरेक्ट प्रोडक्ट घेतल्यानंतर तुम्हाला कुठला बुलियन अल्जेब्रा मिळणार आहे, B1 डायरेक्ट प्रोडक्ट B2 स्टार 3 XOR 3 कॉम्प्लिमेंट 3 0 3 and 1 3. आणि त्याच्यामध्ये ऑर्डर पेअर कुठली असणार आहे, A1 B1 A2 B2 ही आपण कन्सिडर केली. So for this order pair, how we can define these operations like star 3 XOR 3 complement 3 then 0 3 and 1 3. So how we have defined? So for this star 3, now we have to apply this star 3 operation on these two order pairs as A1 B1 star 3 A2 B2. Okay, so how we can define this operation on these two order pairs? Consider A1 A2. Okay, so A1 A2, these two elements belongs to first Boolean algebra, and for this Boolean algebra, which one is similar operation for this star 3? स्टार सारखा अजून कुठला ऑपरेशन आहे, B1 मध्ये स्टार 1 आहे. सो वी कॅन डिफाइन A1 स्टार 1 A2. Okay, now for this B1 B2, these two elements belongs to second Boolean algebra, and in that Boolean algebra star 2 is the similar operation to star 3. That's why we can write B1 star 2 B2. So this is for star operation, that is star 3 operation. So likewise we can define XOR 3, complement 3 and remaining 0 and 1. स्टार ऑपरेशन समजलं का, कसं डिफाइन केलंय?
Yes.
Okay, so likewise we have to define XOR 3. So again A1 B1 XOR 3 A2 B2. Now check here, A1 A2, these two elements belongs to first Boolean algebra, and in that Boolean algebra this XOR operation is XOR 1. That's why we have written here A1 XOR 1 A2. Now check B1 B2, these are the two elements belongs to second Boolean algebra, and in that Boolean algebra XOR 2, this is the operation. So B1 XOR 2 B2. So likewise you can take complement. So A1 B1 triple complement means what? For this first A1, this belongs to first Boolean algebra, and there we have written complement as A1 complement. Then for this B1 double complement. Why we have taken here double complement only? Because B1 belongs to second Boolean algebra, and their complement operation is double complement. That's why B1 double complement. Now 0 3. 0 3 means what? This will consist of set of elements 0 1 and 0 2, and 1 3 will be consist of elements 1 1 and 1 2. So likewise we can define direct product between two Boolean algebras. Have we understood this definition now?
Yes, ma'am.
Okay, good. So today we are going to stop here. Just give me presentee. Roll number 1,
Yes, ma'am.
2,
Yes, ma'am.
3. Roll number 3, 4,
Yes, ma'am.
5, 6, 7, 8, 9,
Yes, ma'am.
10,
Present, ma'am.
11,
Yes, ma'am.
12,
Yes, ma'am.
13, roll number 13, 14, 15, 16,
Present, ma'am.
17,
Yes, ma'am.
18, 19, 20,
Present, ma'am.
21, 22,
Present, ma'am.
23,
Present, ma'am.
24, 25,
Yes, ma'am.
26, 27,
Present, ma'am.
28, 29, 30,
Present, ma'am.
31, 32,
Present, ma'am.
30, okay, 33,
Present, ma'am.
34, 35, 36, 37,
Yes, ma'am.
38, 39, 40,
Present, ma'am.
41, 42,
Yes, ma'am.
43,
Present, ma'am.
44, 45, 46, 47, 48, 49,
Yes, ma'am.
50,
Present, ma'am.
51,
Present, ma'am.
52, 53, 54, 55, 56, 57,
Yes, ma'am.
58, 59, 60, 61, 62, 63,
Present, ma'am.
60, okay, 64, 65, 66, 67,
Present, ma'am.
68, 69, 70,
67 present, ma'am.
67. Okay. Check for absent numbers. Roll number 3, 6, 7, 8, 13, 15, 16, 18, 19, 21, 24, 26, 28, 29, 31, 34, 30, 31,
हाँ
34, 35, 36,
35 present.
35, 36, 38, 39, 41, 44, 45
हेलो मैम मैम
is hello
16 is present
15.
16
Okay, okay. 41, 44, 45, 46, 47, 48, 52, 53, 54, 55, 56, 58, 59, 60, 61, 62.
Madam,
Yes.
A60 is present.
Okay. 61, 62, 64, 65, 66, 68, 69 and 70.
Ma'am, 50,
हेलो मैम
ma'am, 56 is present.
मैम
Which one?
Hello,
Hel-
66, ma'am.
50?
56, ma'am, 56.
56. Okay.
66 है 66.
और
हेलो मैम
yes.
हेलो मैम
Hello. Yes. You can
36
speak.
is present
36.
36 present
Okay.
Hello, ma'am.